everyone. So today what we're going to do is talk about the Pythagorean Theorem. And the Pythagorean Theorem is very important when we are solving right triangles. So over here I have a picture of a right triangle. And if you notice, the sides are labeled A, B, and C. And the side C over here is the longest side of this triangle, which is across from that 90-degree angle. Remember, the longest side is across from the biggest angle. And so our hypotenuse, or side C, would always be the largest side of that triangle. So Pythagorean theorem is only used for a right triangle, and it's used to find the sides of that triangle. And A and B are called the legs. Those are the two sides that are not the longest sides. They're the ones that touch that right angle but not across from it. C is called the hypotenuse. That is the side that's across from that right angle. The Pythagorean theorem states that if you take the two legs of that triangle, you square them and add them together, it's going to equal the hypotenuse squared. In other words, the first leg, A squared, plus the second leg, B squared, equals the hypotenuse, C squared. And we're going to use that formula to do some examples, okay? So let's look at number one. If you notice with number one, the side that we don't know is this side right here. And that side is across from our right angle. So this X right here would be our hypotenuse. In other words, that is our side C. So the other two sides that we have, the legs, are 9 and 12. One of these is A and one of them is B, and it does not matter which one you label as A or label as B. So for our Pythagorean theorem, we're going to plug in and we're going to solve for C. So A, I'm going to call A 9. So we're going to say 9 squared plus B is going to be 12. 12 squared equals C squared. Now what we'll do is we'll work out this side over here. We're going to find 9 squared plus 12 squared. So 9 squared is 81. 12 squared is 144 equals C squared. And now I'll add those together. I get 225 equals C squared. Now that I have this C over here that's squared, to get rid of that squared, I have to do the opposite operation. And the opposite of a square is taking the square root. So we're going to square root both sides. Okay, and now we're going to go to our calculator, and we're going to take 225, and we're going to find the square root of that. Okay, and the square root of 225 is 15. So we can safely say that C equals 15, and our units were centimeters, so 15 centimeters is my answer, and that is the length of the hypotenuse of that triangle. All right, so let's look at number 2. So if we notice with number 2, X is over here, and this side touches that right angle right there. So this is one of the legs. The side across from that right angle measures 5, so 5 would be our C. So we would say in this case, as we plug into that Pythagorean theorem, A squared plus B squared equals C squared. A in this case can be either X or 3, and I'll use A as X. Just to write it first, X squared plus, and then I'll put in 3 for B, 3 squared equals C is our 5, 5 squared. So X squared plus 3 squared is 9, 5 squared is 25, and now we have to get X by itself. We're going to subtract 9 from both sides. So X squared equals 25 minus 9, which is 16, and then I will square root both sides to get rid of that square. And so X is going to equal the square root of 16, which is 4. And there you have it. And the units are miles, so we're going to put miles right here. Okay, so that is the length of that leg. Okay, let's do another example. All right, number 3. So if you look at this example, you notice that the side across from that right angle, right here, that side C is 14.9. That is our C. X is one of the legs, and 11 is one of the legs. So let's write the Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to call A X. X squared plus 11 squared equals 14.9 squared. Okay, so now we'll have X squared plus 121. That's 11 squared, and I need to put 14.9 in my calculator. Don't have that one memorized. 14.9 squared equals 222.01. 222.01. And now we're going to subtract 121 from that. So let's do that. Pull up that calculator. So minus 121, and that gives me 101.1. So x squared equals 101.1, and now we square root both sides to find out what x is. So we'll take a square root of that, equals, let's say 10.05. Let's round it to the nearest tenth, so we'll call that 10.1. So x is going to be 10.1 inches. Measurement in inches. There you have it. Okay, let's do another example over here. So number 4, now we notice that x is on the hypotenuse. That's the side across from the right angle, so that will be our C. The other two sides will be our A and our B, our two legs. So we'll have 13.7 squared plus 14.8 squared equals x squared. Remember, a squared plus b squared equals c squared. Okay, so let me erase those little dots there. Okay, now let's go to the calculator. Now what we can do is put 13.7 squared plus 14.8 squared. I could kind of type that in all at once, and that gives me 406.73. So let me write that down. 406.73 equals x squared. And now we'll square root both sides. Grab my calculator again. So we'll take the square root of that, which is going to give me 20.1675. So let's round it to the nearest tenth, which will be 20.2. So x equals 20.2 kilometers. Okay, and y'all, that's the Pythagorean theorem. Okay, a couple more examples on the next page. So let's kind of flip over to that. Number 5, for this one right here, we need to find x. And x is over here. Do you notice how we have two right triangles? There's a right triangle over here. And if this is a right angle, then this is also a right angle. So we also have a right triangle over here. Okay? Now you notice that we don't know the dotted line here. We call that the altitude of the big triangle there. So since we don't know that dotted line, we need to find it first before we can find x, because we know this side and this side. So to find the third side of the triangle, you need to have two sides. So if we can find this leg here first, then we can find x. So that's where we want to start. So let's start with the smaller triangle, and I will highlight that, not smaller triangle, but the triangle on the right is what I meant to say. Let's start with this triangle here. Okay, now y'all might can take a wild guess of what x is going to be, but we're going to do the math and we'll see what happens, okay? I think your instincts might tell you exactly what x might be, and we'll talk about that in just a little bit. So this side here, we don't know. I'm going to call it a. So a squared plus this side over here is another leg, so that's going to be b squared equals, our c is going to be 6, so 6 squared. So we have a squared plus, and we're going to take 3.8 in our calculator, 3.8 squared, which is 14.44. So 14.44 equals 6 squared is 36. And now we'll subtract the 14.44 from both sides. Okay, so a squared equals, bring our calculator back up. So we got 36 minus 14.44, and now we'll get 21.56, and then we'll square root that. So square root both sides, and 21.56, square root it, is 4.6 is what we get here. So this means that the hypotenuse, not hypotenuse, but the altitude is 4.6, this side right here, one of the legs of that triangle. Now we can find x. Now that we know this side here is 4.6, we can now find x. So 4.6 is one of our legs, x is another leg, and that 6 is our hypotenuse. So we'll say x squared plus 4.6 squared equals 6 squared. So x squared plus, let's get our calculator, 4.6 squared is 21.16. So we'll round that to 21.2. Actually, I'm going to keep that until we finish the problem, and then we'll round to the nearest tenth to keep it more accurate. And so now we'll take 36 minus 21.16, which is 14.84. So we subtracted that, which is, we said 14.84. And now we'll square root both sides. And let's see what we get for x. Okay, so square root this, hit enter. 3.85, which rounds to 3.9. Now, if you notice, the thing I wanted you to see is that this side is the same as that side. And since this is perpendicular, these two should have had the same measure. But a lot of that is probably because we had to round. So we rounded this answer, which made this an even more rounded answer. So that side probably, to be more accurate, would be 3.8 because these two should have the same measure. So I was wondering if you guys caught that or not. But it did, because we had a more rounded answer, we ended up with 3.9. So as we move on to number 6, there's actually a problem with number 6. The measurements do not work out right. So we're going to omit number 6 and we're not going to do this one. Okay, so we're going to go on to number 7. All right, number 7. A ladder is leaning against the wall. If the ladder is 10 feet tall and the base of the ladder is 4 feet from the base of the wall, how far up the wall is the top of the ladder? So it always helps if we draw a picture. So I'm going to draw my wall. I have a wall right here. Okay. And we'll have the ground. So here's the ground. And the ladder is leaning against the wall. Like that. Okay. And the wall and the ground make a right angle. So right here we have a right angle. The wall and the ground make that right angle. And we know that the ladder, they tell us the ladder is 10 feet tall. And the base of the ladder down here is 4 feet from the base of the wall. So this piece right here is 4 feet. And they're asking us how far up the wall is the top of the ladder. So we want to know the distance from here to here. That's what we're looking for. So the ladder itself is the hypotenuse. The ground would be either A or B. And then what we're trying to find, the measurement of the wall, I'll call that W for wall, we're trying to find that height. So W would be our A, 4 would be our B, and 10 would be our C. So we would say W squared plus 4 squared equals 10 squared. And so W squared plus 16 equals 100. And now we subtract 16 from 100. So W squared equals, what's that, 84? And so now we'll square root both sides, and let's see what we get. So 84, square root of 84, which is 9.165, so we'll say about 9.2. So W is 9.2 feet. There you have it. There we go. Didn't mean to draw two equal signs there. All right, so 9.2 feet is the answer for the height of that wall. And there you go. Okay. Number 8, you have the space for a TV that measures 50 inches wide and 30 inches tall. So let's draw a picture of that space that you have. So a TV, if you can imagine, is a rectangle, okay? And the space on your wall is 50 inches by 30 inches. What size TV should you buy to fit the space? And we want the biggest TV that's going to fit in that space. So here's a hint. TVs are measured by their diagonal. So when you go out and you buy a TV, that measurement on that TV is the diagonal of the TV. So I need to know what's the biggest TV I can get to fit on that space in my wall. And so the diagonal of this rectangle is the hypotenuse of one of the two right triangles that are formed when I draw that diagonal. So x is what we're looking for, which would be our c. So we would say 30 squared plus 50 squared equals x squared. And so 30 squared is 900. Okay, meant to put a plus sign there. And 50 squared is 2500, and that equals x squared. And so now we'll get our calculator, we'll add those together, 900 plus 2500, which is 3400. 3400 equals x squared, and now we'll square root that, and let's see what we get. So we'll square root 3400, square root that, and looks like a 58.3 is what we get. So 58.3 when we square root, and I don't know if a TV comes in a 58.3. So we would probably have to size down to probably a 55-inch TV, because I believe they go like every 5 inches. So we would say that the biggest TV that would fit in this space would be a 55-inch TV. There you have it. Okay. Now let's talk about the Pythagorean Theorem converse. Okay. So what you need to know about the Pythagorean Theorem converse is the triangle is going to be a right triangle if the Pythagorean theorem works, meaning that if a squared plus b squared is c squared. And what I'm going to do is I'm going to write the c squared first. I'm going to say c squared equals a squared plus b squared. Write it a little backwards here, because what we want to do is we want to compare everything to that hypotenuse. So if c squared exactly equals a squared plus b squared, then we know we have a right triangle. If the triangle is acute, then c squared is going to be less than a squared plus b squared. That hypotenuse squared is going to be smaller than the two other sides squared added together. And if the triangle is obtuse, then c squared is going to be greater than a squared plus b squared. Important things for you to know: that C will always be the largest side. Just remember that. C is always the largest side. Whether it's a right triangle or not, we're going to call C the biggest side. Always write C squared first. This will help when you go to compare. Because we're using less than and greater than, we have to compare with C squared being on the left. It needs to be written first. And please know that if you see triangles, if there are any triangles, they are not always drawn to scale. You can't look at the triangle and say, oh, that's a right triangle because it looks like it is. You can only say that if you see a box, or if this is true. That's the only way we can show that it would be a right triangle. Okay, so let's look at what we have here. So first of all, we need to determine if the three side lengths actually make a triangle. And once we determine that, then we can classify the triangle as either right, obtuse, or acute. Okay, so let's look at number 9. Do y'all remember what we did when we tried to decide if if the three measures actually made a triangle? Well, you had to add the two smallest sides together and see if they were bigger than the third side. If they were bigger than the third side, then it did make a triangle. Now y'all think about this. If I add 36 and 48 together, is that number going to be bigger than 60? Yeah, you can definitely tell that, but 36 plus 48 is definitely going to be greater than 60. And if you just want to see 36 plus 48, that gives me 84. And 84 is definitely greater than 60. So it does make a triangle. So we don't have to worry about that. Now I need to decide, is it going to be a right triangle, an acute triangle, or an obtuse triangle? So we're going to find c squared and we're going to compare it to a squared plus b squared. Now remember, c squared, c is going to always be the biggest side. And in this case, that will be 60. So we're going to say 60 squared equals 36 squared plus 48 squared. Doesn't matter which one's a and b, but it's very important that you always get c correct. So now we're going to square these. 60 squared is 3,600 equals, and let's square that 36. So 36 squared is going to be 1,296. 1,296 plus, and then we're going to do 48 squared. 48 squared, which is 2,304. 2,304. And you know what? I probably shouldn't put an equal sign here yet because I'm not sure what it's going to be. So I'm going to change that to a little question mark because we need to know, are they equal? Are they the same? Or is c squared bigger or smaller? So let's check. So we're going to take 1,296, 1,296, and we're going to add 2,304, 2,304, and look at that, we get 3,600. So they are the same. So 3,600, 3,600 equals 3,600. So that tells me since they are the same, they equal, this is a right triangle. So we would safely say that this is a right triangle. So we classify it as right. Okay, let's look at number 10. On number 10, we have 8, 5, and 15. Okay, so first of all, let's make sure that it makes a triangle. So y'all, what is 8 plus 5? Well, that is 13. And 13 is less than 15. So since these two sides added together are not larger than the third side, this doesn't even make a triangle. So we say not a triangle. And guess what? We're done. We don't have to go any further because it doesn't even make a triangle. Here we go. All right, let's go to number 11. All right, so let's check to make sure it's a triangle first. 3 plus 8 is 11, and 11 is bigger than 10, so it does make a triangle. So now let's decide what type of triangle that we have. So remember, C is the biggest side, so we take the biggest side, square that. We're going to compare it to the other two sides, so that would be 3 squared plus 8 squared, and let's see what we get. 10 squared is 100. That's going to be something to 9 plus 64. Now, when you add 9 and 64 together, y'all, is that going to be bigger than 100? No, it's not. So we get, what, 73? So 100 is going to be actually bigger than 73. So since c squared is bigger than, let me point, c squared is bigger than a squared plus b squared, then we have an obtuse triangle. So this one would be obtuse. Okay, let's look at number 12. All right, so first of all, let's check to make sure that this does make a triangle. So we have 9 plus 12, which equals 21. And 21 is bigger than 13. So yes, it does make a triangle. So C is going to be the largest side, which is 13. 13 squared is something to 9 squared plus 12 squared. We have to figure out that comparison. And 13 squared is 169, I believe. So let's, just to show you, 169 is something to 81 plus 144, which is 12 squared. Now we'll add 81 and 144. What do you think is going to happen? 81 plus 144 is 225. 169 is what to 225? It is smaller than 225, so this triangle is going to be an acute triangle. And y'all, that is the Pythagorean converse. Hope you have a great day.